Today's webinar, we'll be talking a little bit, I will go through the agenda. First of all, thank you for attending this webinar. My name is Antoine Abi Antoun. I am Director for Patton in Middle East and Africa region. Today's webinar, we are doing it in collaboration with Sitec. I will start with the webinar with a brief overview about Patton, who we are, what we do, etc. Then my colleague Yara, our field application engineer and tech support manager for MENA region, will talk a little bit about Patton Smart Node solution, which is our brand name for voice over IP gateways, routers, integrated access device, session border controllers. And she will present some applications. After that, Sitec team, Femi, will be talking about smart node use case scenarios. He will be doing basic configuration. He will go through some basic configuration with for smart node, then smart node for 3CX, and 3CX configuration with Patton Smart Node. Very quickly, who we are a US-based company. Our company is based in Maryland, USA. This is where we develop, we manufacture every single product. So our products are US-made. We have, we are a multinational company, a homegrown technology. We do our own product, we manufacture them. We have our in-house US manufacturing, and we are a very flexible company, not a multi-billion-dollar company. However, we are a company that is passionate and creative. We are doing business in 154 countries around the globe. We have 14 offices that are Patton offices. Our office for Middle East and Africa region is based in Beirut. This is where we are handling EMEA as sales, technical sales, pre-sales, and first level of technical support. We have 7 technical assistance centers which are around the globe, which means we can cover like 24 hours of free technical support. And all these are Patton offices, and we have 3 subsidiaries for logistics centers, which are in Maryland, USA, Switzerland, and in Hungary, Budapest. One key feature with Patton is that we have free lifetime tech support, unlike other vendors. We have free lifetime tech support. We have free lifetime software upgrade. Any client, any channel, any partner who have bought a Patton product will enjoy this free lifetime, and we don't have any hidden cost for technical support. Also, we do have 24/7 premium support for operators who request 24/7 with 2 hours response time. We have SLAs for this type of support. We do have what's called Smart Node certification trainings that we do worldwide. We have a list of trainings which exist everywhere in the world. Also, we do customized trainings for operators and channels. We are very flexible in that area. What are our product range? With Patton, we have different product range that we have been manufacturing since 1984. It's over 30 years now in developing and manufacturing product. And our product brands are Smart Node is our brand name for VoIP gateways, routers, and session border controllers. This is our main product today. It's like our winning horse at Patton. CopperLink is another product range. We have an extensive product range of Ethernet extenders, routers, etc. Body is our product for bonding, load balancing, failover solution that ensures bandwidth robustness and network survivability. This is a load balancing router that supports 7 WAN interfaces. We also have low-cost IP routers, DSL modems, CPEs, network termination units, and we have multi-service access platform for EFM solutions, concentrators, TDM, and IP concentrators. Major market served with Patton product, we have unified communication is our leading market today. 80% of our business is for unified communication, and this is where we are mostly developing our solution. And Smart Node is a leading product for unified communication solutions. CopperLink and Body are second runners. We also have, as a market segment, we address cloud services and security with Body, and we address industrial networking and communication with CopperLink and Body, and also Smart Node. This is a brief introduction about Patton, who we are and what we do. Now I will give the hand back to my colleague, Mrs. Yara, to start talking about Smart Node solution, Smart Node products, and applications for Smart Node.
Okay, thank you, Antoine. Just to make sure I see my screen. Just one moment. Okay, so I'm Yara, as Antoine introduced me before. I'm applications engineer for the Middle East and Africa region. And I will give you a small overview on Patton's product and main applications where we can use our gateways. First of all, the gateway is needed in applications where we want to interconnect a TDM network to a full IP network. Everything in the past was TDM. Now the trend is to move everything to IP. But during this transition, definitely we will face applications where we will have at the same time a TDM network and an IP network, and we need to interconnect these two together. And this is where the gateway stands and will provide a smooth transition between the TDM network and the IP network. Our gateways not only provide call switching, which means switching the call from IP to TDM or from TDM to IP, but it also allows to have a protocol conversion from SIP to H223 and others. Also, it ensures encoding and decoding the voice using the appropriate codec selected on the gateway. Plus, on different models, we support IP routing. So the gateway can at the same time act as an IP router to route your data traffic. We have different kinds of VoIP gateways. We have gateways starting from 1 to 2 ports, which are mainly targeting residential or small offices. Then we have gateways going from 1 to 120 ports for small enterprises. And we have also carrier-grade gateways supporting 64 or STM1 ports. And we will talk in the next slides about the different models that we have. On the analog side, we have gateways supporting 1 to 32 analog ports, either FXS or FXO. We have gateways supporting up to 8 PRI ports, and gateways supporting up to 4 E1 ports. We have also another range of gateways, which is the SN10K series, that support up to 1,024 E1 ports on the cluster-based solution and up to 64 STM1 ports. All of our gateways are using basically the same software. We have gateways using the Smartware, which was our current and previous software, and we have recently launched a new software called the Trinity. All our gateways are using either one of these two softwares. The gateways will be responsible for call control, for switching the call, for deciding how to route the call and to which destination to route the call. Transcoding is also supported on these gateways, so we will see applications how transcoding can be done on the gateway. Quality of service can also be ensured, so whenever you have data traffic on the link, you can also be sure that priority is given to the voice to have a good quality for the voice. Survivability can be achieved, and we will see applications of that. You have also different options for the WAN uplink, either DSL, whether J.SH DSL or ADSL, or maybe fiber uplink or others. We will see how the gateway can also ensure a role for security and how it solves problems of interoperability between different vendors. Our gateways are classified into 4 main categories. We have the gateways only, which is a simple gateway doing only the role of a gateway, from TDM to SIP and SIP to DDM, for example. We have also gateways having routing features. So in addition to the VoIP gateway function, the gateway also acts as an IP router. We have the IADs, the integrated access devices. These are at the same time a VoIP gateway, an IP router, and they have an uplink. The uplink, besides the Ethernet port, it can be fiber, DSL, ADSL, X21, E35, or other. And finally, we have the ESBR routers, and the Enterprise Session Border Router is only for SIP to SIP calls, an application where a TDM port, a telephony port, is not required. Then the ESBR will allow to have SIP to SIP calls, and we will see a little bit later on applications using the ESBR. The ESBR is also an IP router, so it has also all the functionalities of an IP router. On these gateways, we can optionally also enable transcoding, so we can convert from one codec to another according to our application and need. Let's see now a quick overview on the different analog gateways that we have within our product range. We have different analog gateways. The first one is the MATA, and this is a simple adapter, an ATA, with one port. It can support definitely, of course, one simultaneous call, and it has one Ethernet port. The bigger range is the 4110. With the 4110, we can support up to 8 FXS or FXO ports. It has only one Ethernet port, and this is a simple gateway without any IP routing feature. The 4520 in the third column is similar to the 4110, but in addition, it has a built-in IP router. So it supports IP routing features such as quality of service, VPN, ACLs, and so on. The HTTP server as well. The 4830 series is an IAD. It's like the 4520, meaning it's a simple IP gateway with built-in router supporting up to 8 analog ports, either FXS or a mixture between FXS and FXO. And it has a WAN access port, either DSL, X21, or V35. The 4110, the 4520, and the 4830 series, as I said, support up to 8 ports. If you are looking for more ports, then you'll have to be looking at the 4300 series. The 4300 series supports 12, 16, 24, or 32 analog ports, either FXS or FXO. The 43000 series is a simple gateway, so it has only one Ethernet port. If you need a gateway plus IP routing, then we have to look at the 4400 series. 4400 series supports also 12 to 32 analog ports. It has 2 Ethernet ports and supports IP routing features. The 2 Ethernet ports, one can be connected to the WAN side and one will be connected to the LAN side. Finally, the 4900 series is similar to the 4400 series. It also has 2 Ethernet ports and supports 12 to 32 FXS or FXO ports. And this is the analog series. We also have ISDN gateways having BRI ports. I will not focus very much on the BRI ports because basically they are not so common in the Middle East, the Africa region. But we do have gateways such as the SNDTA with 1 or 2 BRI ports. Same as well for the 4120 series. And these are only simple gateways. The 4130 is a new gateway running the Trinity software. As I mentioned before, the Trinity is our new generation of software supported on our new generation of gateways. The Trinity will have a lot of features such as firewall, for example, or IPv6 support. We do have on our website a very detailed comparison between the two softwares, Smartware and Trinity. The 4130 series supports up to 4 BRI ports. And this is also a simple VoIP gateway without any IP routing feature. It has one Ethernet port. The 4630 series supports 3 or 5 BRI ports with a maximum of 8 simultaneous VoIP calls. This is also a built-in router having 2 Ethernet ports. The 4650 series is similar to the 4630, but in addition it has a WAN uplink port such as DSL, V35, and others. We do also have the 4660 and the 4670 series. These are gateways having a mixture of BRI, FXS, and FXO port. They can support up to 12 ports and 36 simultaneous calls, depending on which number of port and which type of port is available on the unit you select. These are VoIP gateways supporting IP routing features and are available in a 4-port switch, Ethernet switch. The 4670, in addition, has a WAN access port. For the PRI gateways, the E1 gateways, we also have a selection of gateways. We have the 4170, which is our new released PRI gateway. It's a simple gateway without any IP routing features, supporting 1 or 2 E1 ports and up to 30 calls simultaneously. The 4970 supports up to 4 ports and 120 simultaneous ports. 4980 is similar to the 4970, and it has IP router built in. The 4990 has, in addition, a WAN uplink. Now we come to the IADs. The IADs are basically more or less what we have seen a little before in the previous slides, but they have, in addition, a WAN uplink. The WAN access port, either DSL, fiber, V35, X21, EFM, or other. They are available with a different selection of ports, BRI, FXS, FXO, E1s, or also as ESBR, such as the 4200, the 5200, the 5300, and the 5490, which we will see also in the next slide. And we come here to the ESBR's product. The ESBR products do not have any telephony port. These are used only for SIP-to-SIP calls. So you will not find in this, except like the last two, which are the new product. They do have a telephony port, either the BRI on the 5530 or a PRI port on the 5570. The ESBR range supports calls from 32 simultaneous SIP sessions up to 512 on the last two products, which are our latest releases. Transcoding can be supported on these ESBRs, as you can see in the table. And we will see in the next slides applications on the use of ESBRs. And finally, a quick overview also on the SN10K product, which is the carrier-based product. They come either with this SN10-100 supporting up to 8 E1 ports, or the SN10-200 supporting up to 64 E1 ports, or 1 STM1, or the 10-300 supporting up to more than 1,000 E1 ports, or 15 STM1. All these products are running the Smart Media software, which is a different software from the Smartware and the Trinity that I had mentioned before on the other range of products. Now, we will start talking about applications requiring the gateways. The gateway can be used in different applications, such as SIP trunking to a provider, for example, to a VoIP provider, or SIP trunking to a legacy PBX for integration of a PSTN line, or for integration of a legacy phone. We can use it for VoIP routing as an ESBR, for example, for routing from different SIP networks for survivability. The VoIP gateway can be used for fax over IP. We can integrate a remote office also using a VoIP gateway or to a carrier network. We can integrate to vendors using proprietary protocols such as Link. And the gateway can also be used as a demarcation point. And let's see now applications of similar applications using the gateway. The first one is a very basic application with 3CX for PSTN integration. So we can imagine here that we have an enterprise having a 3CX phone system. And they need to connect their local office to a PSTN line to make outgoing calls or receive external calls. And for this, a gateway would be needed, such as the 4114, having FXO ports. The FXO port will enable to connect to the PSTN, and the Ethernet port of the gateway will connect to the customer's LAN. And the gateway will allow to pass calls from the SIP network on the 3CX side to the PSTN network on the FXO side. So now the customer can make outgoing calls through his PSTN line and receive incoming calls from the PSTN line on his 3CX server. And that is a very common use case for 3CX. Another application with 3CX is a remote office integration. So we have the headquarter office with 3CX phone system, and they have a remote office that they need to connect to their main office. An application described in this diagram is using a gateway at the remote office. The traditional phones in the remote office, which are regular analog phones, will be connected to the gateway in the remote office, and the gateway in the remote office can directly register on 3CX or can communicate to another gateway located also at the headquarters in order to integrate the remote analog phones to the 3CX phone system located in the head office. The gateway in the remote site can also be connected to the PSTN for making external calls, or you can imagine a scenario as well where the external calls will be routed first to the headquarters, and then the gateway in the headquarters will route them through the PSTN. Another application is for fax over IP. The gateway having an FXS port can also connect to an analog fax machine, standard regular fax machine, where the user can also send fax and receive fax using their existing analog fax machine. Final application with 3CX is for legacy phone integration. So we have an enterprise having a 3CX phone system, but they also have some traditional phones, analog phones, that they do not want to get rid of. They want to keep them as an investment, and they need to connect them to 3CX phone system. They would definitely then need a gateway. The phones will be connected to the gateway, and the gateway will connect to 3CX server so that the phones will look like extensions on 3CX and will be able to make calls to different other IP phones, and other IP phones can also make calls to this traditional phone. And this is how we're integrating regular phones, analog phones, with a 3CX IP-based system. In different applications also, ESPRs would be needed. Even if we do not have any telephony ports requirements, such as FXS, FXO, PRI, it is recommended to use an ESPR while connected to the VoIP provider, such as in this example. We have a customer having his own IP-PBX system, such as 3CX, and he wants to connect his system to a VoIP provider. We recommend also the use of an ESPR as a demarcation point between the two VoIP networks. This will provide security and will protect the enterprise network and the topology of the network from the outside world and the internet. Here's an application using an ESPR, the 5570, which is an ESPR having a PRI port. In this application, we have an IP-PBX at the customer side with his SIP phones. We also have the LAN with all the PCs on the LAN. And also the customer has an IP-PBX. We can imagine that they had initially a legacy PBX, and they want to migrate from this legacy PBX to an IP-based PBX. But they want to do a smooth migration, and they do not want to remove everything on the legacy PBX and just keep only the IP PBX. They can use the ESPR to interconnect the IP PBX to the ISDN PBX. Can be any analog PBX as well. But since in this application you're using the 5570 having PRI ISDN ports to be connected to the PBX, so we're providing an example with PRI. So in this case, the 5570 is connected from the first SIP side to the IP PBX, It can as well provide to the red cloud, which is also SIP, connecting to a SIP provider, a VoIP provider. The gateway is also connected through PRI port to the existing PBX, having a new one part, for example. We can also connect the CSPR to the PSTN, also over a new one line provided by the PSTN provider. And here in this application, the ESPR will have different functions. It will provide SIP demarcation. That means it will separate the internal network from the public internet or from the provider's cloud. Plus, it provides IP routing. So all the data traffic coming from the different PCs on the LAN side will be routed through the ESPR out to the internet, for example. Plus, the ESPR will do QoS, quality of service. So whenever we have outgoing traffic or incoming traffic, VoIP traffic and data traffic simultaneously, the ESPR will give priority to the voice, for example, to ensure we have a very good quality for the voice, even in case of simultaneous data traffic on the line. Also, the gateway here, or the ESPR, provides fallback call routing. That means if there's a problem on the SIP network and the outgoing call cannot be routed through the VoIP provider, the gateway, since it is connected to the PSTN, can route the call out to the PSTN using the PSTN network. The gateway will also decide on the destination for all outgoing calls. We can have tables configured inside of the ESPR and decide where to route the call depending on our criteria and how we decide to configure the routing tables. So, for example, national calls, we can decide to route them through the PSTN network, and international calls, you can decide to route them through the SIP network, through our VoIP provider, who might be providing very good rates for international calls. On the 5570, you also have a failover relay. That means even in cases where we lose power on the unit, there is, for example, a disaster, an electricity problem in the building, and the unit is no longer powered, there is a failover relay inside of the unit connecting two PRI ports together. So users behind the ISTN PBX will still be able to make outgoing calls over the PSTN networks. So this is a fallback relay in cases where the unit loses power. Let's see now some advantages of using voice over IP gateways in different applications. In carrier applications, for example, where a VoIP provider is connecting to different customers, a major problem for them is interoperability with whatever the customer has. Using a gateway will provide the carrier a unique SIP interface, no matter what the customer will have on his network side. So a VoIP provider will always be installing a smart node device on the customer side and will not have to worry about interoperability of the customer's IP PBX with his own soft switch or VoIP equipment. So the interface to the provider, the customer's interface to the provider will always be a smart node. And the provider will know that the smart node is always interoperable with his own equipment, soft switch, IMS, or router. And the smart node, since the smart node also is interoperable with practically every IPPBX vendor or SIP phone vendor in the market, then the customer will have no issue connecting his IPPBX or TDM PBX, legacy-based PBX, or SIP phone to our gateway. Another key function of the gateway is the back-to-back user agent feature. In this application, we have the customer having an IPPX server with the IP phones, and he needs to connect to the IT SP provider, to the Internet Telephony Service provider. The gateway, in this case, is acting as a back-to-back user agent client. In other terms, the gateway will act as a demarcation point and will allow to protect the customer's network from the ISP's cloud. So from the internet side or from the cloud side, we will not have any visibility on the customer's topology, and this will ensure security. And plus, we will see also how the gateway will allow to resolve interoperability issues between the two sides. The first interoperability issue can be transcoding. So your IPPX, your IPPX may support some codecs which are not supported or used by your service provider. The gateway can support transcoding. That means if your IPPX is using, for example, G711, and your VoIP provider is only using G729, then you can use a gateway to ensure this transcoding, this translation of codec, if you want, between the two SIP networks to enable to make calls between these two SIP networks. Also, quality of service, as I mentioned before. In this application, where the gateway is acting as an edge router for your application, you will be having VoIP traffic and data traffic passing through the gateway simultaneously. The data traffic will try to use as much as it can from the bandwidth, and this will definitely affect your VoIP, your voice quality. The audio might be breaking, or you might have noise on the line, and the voice quality will not be acceptable. This is why having quality of service is very important. The voice quality, when you have quality of service configured, the voice quality will remain acceptable, and you can give priority to the voice if needed in your application in order to make sure the voice quality is not affected by any data traffic. The SIP registrar is also a key feature on our gateways. Our gateways can act as a SIP registrar, which means that you can have IP phones registered directly on the gateway. And this can be a unique feature. So in small offices, for example, in which you don't want to install an expensive IPPX, you can have the IP phones registered directly on the gateways. Or also, you can use the SIP registrar for survivability in cases where your IP phones or your SIP devices are registered to the VoIP provider. But in case the VoIP provider network is failing for any reason, and your phones cannot register to the VoIP provider, you can take use of the SIP registrar feature and have the IP phones registered on the gateway itself in order to still be able to make internal calls even if the link to the IP provider has been cut either due to a network failure or to a failure at the VoIP provider. Another key feature of the gateway is interoperability between different vendors. So, for example, Link is not using the same SIP standard used by other vendors, and not all providers or SIP devices are interoperable with Link. You would need our gateway, in this case, to solve this interoperability problem between Link and the VoIP providers. Also, usually, whether Link or other IPPX the IPPBX administrator prefers always not to have his device connected directly to the public internet or to the SIP trunk directly. They prefer to have a gateway in between for all the security issues I mentioned before. So for these two reasons, the gateway is recommended. It will be an ESPR, for example, in this case, to connect the LAN side to the VoIP provider. Here also is more or less similar application where we need to connect an IPPBX such as Link in this application to many different devices, SIP devices that are not interoperable with Link. They are not compliant with Link, and the customer wants to integrate them with this IPPBX. Then also an ESBR here will solve this interoperability issue. All the SIP devices will be connected to the ESBR, such as an IP paging system or an IP intercom system or an IP speaker. They will be directly connected to the ESBR, and the ESBR will be connected to the IPPBX. And whenever a call needs to be done between the IPPBX and these SIP devices, the call will be possible because the ESBR will act as a gateway between these two systems and will ensure we can have calls between these two systems. Last product to mention is the VoIP appliance we have. This is a VoIP appliance including a built-in SIP gateway. We have two products actually. One that has already a 3CX free edition pre-installed on the appliance, and another appliance that comes without any operating system installed or any IPPBX installed, so you can install the one of your choice. That would be an appliance acting at the same time as IPPBX and as a gateway, since it has also a gateway integrated. We have listed here two models, but we also have others. The first one port, and the second one has an 8FXS port. In applications where the customer would like to have the IPPBX and the gateway in a one-box solution. Some of our partners, IPPBX vendors such as Microsoft, 3CX, Broadsoft, Asterisk, and others. So we're interoperable with practically every vendor, SIP vendor in the market. Soft switch partners also, we have Alcatel-Lucent, Serpac, Huawei, Broadsoft, and others also with whom we are certified. Different VoIP providers around the globe are also using our gateways. Here are some references. And that was all for the overview regarding the Patton products and the applications. If anybody has any questions, you can raise your hand on your webinar application, and then we can unmute you and you can ask your question. Or you can either type your questions in the chat section, and we will make sure an answer will be sent to you. If no one has any question, then I will give the hand to Fami from Sitec. Fami will talk about also some applications and how to configure the smart node with 3CX, as well as how to configure the 3CX when using it with a smart node device. His configuration introduction will be brief. If you need more technical configuration, we do have trainings covering in-depth technical configuration of the gateways and installation. We can definitely organize another session locally, maybe in the UAE, smart node certification training in collaboration with Sitec. if you're interested in having more details on the config of the gateway. Now I will pass on the screen to Fanny.
Thank you very much, Yara, for the presentation. Okay, so as Yara mentioned, this particular demonstration will be relatively brief. We might just go through some basic technology overviews on voice and voice over IP communication. However, I will skim through these topics, and so that we can get into the main part, which is configuring Patton for 3CX. Okay, so a quick introduction to myself. My name is Otuyemi Otufemi. I'm the technical team lead at Sitec. I've been in the industry for over a decade now. We've worked on Linux as well as Windows platform. On Linux, we've worked with Asterisk, FreeSwitch, as well as Yates. On the Windows platform, we've worked with, of course, 3CX, Microsoft Link. I've also worked on the Cisco environment as well, and also attained the CCIE. We have expertise in DJUM and in the DCAP, as well as we are also Patton certified. Okay, so let's see, how did we start? Initially, with regards to transmission of voice, the idea is we started with analog transmission system. Basically, we wanted to take voice and pass it over some kind of medium. If I sit in front of you and I communicate with you, you hear me because of my voice is being transmitted over excuse me, it's being transmitted in the room, okay, for short distance. But for longer distance, we needed to transmit our voice using some kind of signal. And initially, we started with analog transmission system. So basically took the voice, passed it into an analog signal, and pushed this analog signal over some kind of electronic conductor device, maybe in most cases copper. Now, after a while, we realized we faced some problems with analog transmission system. One of the key problems we faced was with regards to recreating or retransmitting the signal. Meaning this, after a certain distance, the signal experienced some kind of, in some cases, interference or distortion. Hence, we started to look at other means of transmitting signals for longer distance. And then came the concept of digital transmission systems. Now, with digital transmission system, what we are transmitting in this case is a sequence of ones and zeros. Now, the idea here is we are not bothered whether this ones and zeros has to do with voice or data or even video. All we know is you just need to transmit a sequence of ones and zeros from point A to point B. What's really cool about this when it comes to interference and signal loss is that unlike analog system where we had to amplify the initial signal due to signal loss, with digital system, all we have to do in this case is just recreate the signals with a repeater. So digital systems can be transmitted in most cases for very, very long distance without experiencing any kind of distortion. All right. So now, on top of analog, on top of analog voice, on top of analog systems, we built some type of voice networks. The voice network that we did, and you often hear this called legacy networks, legacy voice services, is the plain old telephone service rather. This is the service that we are all familiar with, where you get a typical analog connection, and you can connect a rotary phone to that, which is then connected to your exchange. Okay. For digital networks, on digital signals, we built the following type of networks. We built E1 networks, and on the E1 networks we have a couple of flavors: basic rates as well as primary rates. Now there are other types of digital voice services which I wouldn't talk about, but the primary thing with regards to basic rate interfaces, you can get two voice channels for the E1 as well as for the PRI type interface. You could get it comes in two flavors. You have the T1 and the E1. The T1 supports 23 voice channel, and that's used primarily in North America. For Europe and for those of us in the Middle East and North Africa, we primarily use the E1 ISDN PRI voice service. Okay. So let's look at the legacy enterprise telephone network. Now, the legacy enterprise telephone networks usually consist of what? You have a PBX and you have a couple of phones. Now, these phones could be what? They could be traditional analog phones, or in some cases, they could be some kind of digital phones. However, one thing very important is you will have some kind of physical connection from the phone directly to the PBX. And then from the PBX, you would have a connection that goes to the telco. If you want to implement a new service, say you want to add voicemail or you want to add call recording, it usually requires you connecting to some external device, in most cases, or buying a dedicated hardware card or board, which you have to purchase from the provider. Now, that was fine initially for a while, but as technology moved and as enterprise began to evolve and develop, there was a need for something that was much more faster and that was much more flexible. And hence the concept of voice over IP. Now, the primary reason for, one of the primary reasons for voice over IP was to make voice another application on our networks. Most of us in our LAN environments, we are getting minimum 100 Mbps of bandwidth in the LAN, and in some cases, some people are even getting gigabit bandwidth in the LAN. That's if you're connecting to a gigabit switch. Even for the Wi-Fi, now with the 802.11 AC, you can get almost close to 1 gig of wireless network speed. So then comes the question, why do we have to run separate cabling for the voice? Why don't we take our voice and make it another application on the data network? Hence, in terms of cabling cost, it reduces our overall cabling cost. It's much more flexible because at this point, voice is just another application that we can develop. We can have our develop guys add services quickly. And in terms of large environments where you have a telecommunication team, you have the data team, with voice over IP, you bring this team under one umbrella network, and this brings down overhead costs. All right. So now with voice over IP, there are a lot of jargons involved, but the key things I will just talk about in this case is SIP and RTP. Now, SIP is what we call a signaling protocol, primarily meaning it's kind of like I always refer to it as a broker. It comes in, negotiates certain key things, and then it hands off. It hands off to another protocol called RTP. RTP is responsible for transmitting media. Now, the media could be voice, as in my voice that you hear, that you are hearing now. It could also be image in some cases, and likewise, it could also be video as well. So we have moved from the legacy environment, the legacy enterprise telephony environment, where we had the traditional TDM-based PBX, and we're now moving over to the modern telephony environment, modern enterprise telephony environment. And now, something very important you will know here is, you will notice here is that we're now dealing with what we call an IP PBX. Now, the IP PBX is going to take the position of the traditional TDM-based PBX, meaning, of course, all the phones will build some kind of relationship to this PBX, okay? And this relationship is not physical. It is instead logical or virtual, meaning it's going over the IP network, okay? All right. Now, in the modern enterprise environment, you will have IP phones. You may also have soft phones. Now, a soft phone is basically a software that is installed on your PC or your laptop or your smartphone to make it behave like a phone. Meaning, you could receive calls on the on your PC, on your laptop, or your smartphone device. So, 3CX has an excellent 3CX soft phone for PC environment, also for iOS environment, as well as an Android environment, which allows you to receive calls on these devices as well. Make and receive calls. Okay. All right. So this is just an illustration of how the communication will flow. It goes from phone to PBX and from PBX to the other device. Okay. Now, in this discussion, what we've had so far, we just had only the IP PBX, the phone, and the phones, limiting us to only internal communication. Now, if we need to communicate with the external network, we need something to act in between. In most environments, and I'm saying this cautiously, but in a lot of environments, in a lot of countries, although we use the word legacy voice services to describe TDM-based network, this is still the service that is provided by a lot of telcos to enterprises or to end users. So if you are going for a modern enterprise telephony setup in your office and you want to communicate with the external network, you need some intermediary device to act as a bridge between your internal network and the public network. Here comes the gateway, or the VoIP gateway. Now, this is where Patton really gets into the picture, because it has excellent interconnectivity with different types of TDM-based networks, as Yara clearly explained, and also interconnectivity with different types of VoIP environments. Okay, so this is just an illustration of how traffic will flow, incoming calls from the telco down to the provider. Sorry, to the internal network. And the other way around. A call comes in, a call is going out, it's made from the PBX to the telco on the VoIP, sorry, to the VoIP gateway on the private network, and then the VoIP gateway converts this to something that is understandable on the telco environment. So, yeah, so we were introduced to VoIP gateway in the last slide, and now we're going to take a look at what are the characteristics of a typical VoIP gateway. Okay. Generally, a VoIP gateway sits at the boundary of a network. Now, what you define as your boundary will depend on you, the administrator, building or defining or building this network. So your boundary could be the connection between your, say, Dubai office and your Saudi office. That could be your boundary. Your boundary could be the connection between one department and another department. Say, for example, in cases where the departments have different bills, and each departments are responsible for their own telephone charges. Okay, the boundary could be, of course, say you have an enterprise, a single small office, and the connection between your office and the telco. Okay, that is your boundary. Now, the VoIP gateway, of course, the VoIP gateway will sit at the edge or at the boundary between your network and some other network. This network could be a partner network or a telco network or a branch network. Okay. Generally, what it does, it bridges between legacy or TDM-based voice services and modern VoIP voice networks or VoIP services. Primarily saying, on one side, you have either an analog or a digital network, and on the other side, you're going to have some kind of VoIP network. Okay. Another characteristic is it's going to convert the signaling and the media from one protocol to the other. Basically, it's kind of like an adapter, taking in something on one side and releasing the other thing to something else to another on the other side. Why? Because these two sides do not understand or do not speak the same language. So, for example, here we have a connection to a telco. We have an ISDN E1 connection to the telco, and on the internal network we have regular VoIP. So the VoIP gateway takes incoming E1 signals as well as media and converts this to SIP for signaling and RTP for media on the internal network. Okay. All right, so I'm going to run through this, some of the smart node VoIP application, because Yara already explained this in detail, so I wouldn't bore you. I wouldn't dare to bore you on most of these topics. So with regards to Patton devices, you could have them in carrier environments, you could have them in enterprise environment, as well as the LAN environment or small or SOHO environment. So speaking of the carrier environment, you could have smart nodes deployed whereby you have multiple connections, one connecting via VoIP, as well as the other one acting as a PSTN fallback. Okay, and you have the customer premise equipment here. You have the customer premise equipment here, and you have the telco at the back end here. Okay. For the enterprise environment, you can have it act as a branch device or as a PBX or home office provide home office extensions. Now this is really great. For example, in my home, I have the Smart Node 4524, and I'm using it as my router. So it's what connects to my telco via PPPoE, and is also used as my internal to provide IP addresses on my internal network. But being that I'm a bit of a techie kind of fellow, I also have a VoIP. I also have a landline that is also connected to the FXO interface of this device, and I have a couple of wireless DEC phones connected, as well as also wired phones in my environment. So with one device, I am able to provide data networking as well as VoIP networking. Now this same concept can be applied or repeated in the branch office, okay? And as Yara explained, it can act as either one fallback SIP registrar. So in the event that, for example, you have a branch office with, let's say, I don't know, 4, 5, 10 users that are registered with the central office PBX. That's the main office PBX. It could be a 3CX PBX or maybe a Microsoft Link PBX in the main office. However, in the event that the VPN or whatever kind of connections you have between the branch office and the main office goes down, you do not want your users in the branch office to lose all communication or to lose the ability to communicate. So in this case, you could have the Smart Node device function as a backup SIP registrar for the phones in your branch office. Okay. And in the LAN-based telephony environment, you have the Patton devices. Sorry, the Patton Gateway integrates with all major types of PBXs out there, be it 3CX, Asterisk, SNOM, Cisco. Yara already talked about this. You could also have it function as a bridge between your fax environment and your LAN and your IP or voice over IP environment. What do I mean? We've gone into a couple of projects whereby customers clients have rolled out an IP solution, got rid of their traditional VoIP solution, their traditional TDM-based solution, and after they have done this, then they realize that they still have traditional legacy fax machines that have to receive faxes. Okay, Patton has excellent products that you could use, and Patton has support for regular faxing over IP using RTP, or also T.38 fax over IP support. Okay, so this is just an example with details of showing how you could have Patton connect between different sizes of office, from the home office to a sales office to as well as the head office. Okay. All right, so let's look at the configuration. How we can configure Smart Node, the Smart Node in this case, Smart Node configuration. Okay. So when you get it, Smart Node comes as a device. Smart Node comes with two options for configuring. You can configure it via the CLI or via the GUI. This discussion is going to be limited to only configuring Smart Node via the CLI. If you want to configure it via GUI, it's something like this. This is what the GUI looks like. This we can take up in a future date, which will be advertised by our teams. Okay, but this is what the GUI looks like for those of us that prefer to work on the GUI. All right. Now, Smart Node by default comes with an administrator login, which gives you full write access. To log into your device, you enter the username administrator. No password is required, and this account is deleted once a new account is created. Okay. So the administrator account is deleted once you create a new account, and you can add accounts. You can add multiple operators or multiple administrator accounts if you have multiple admins. Now, the operator is a user or an administrator with restricted access, while an administrator is a user with full access. Okay, So you can add multiple accounts type depending on your requirements if you have multiple administrators who will be administering the system. All right. Now, with regards to Patton, when you're configuring Patton, you have to kind of, I always look at it like this, you have to decouple the physical port from the logical port or logical interface. Okay, so what do I mean? When configuring Patton devices, you have, let's focus first of all on data configuration. So if I am going to take this, and let's say we're going to focus only on this side of the configuration. Okay, so just data. We're just going to focus on here. Okay, just data. So think of it. It's equivalent to configuring a router. You have the LAN ports. By default, if it's the you have some of them that come with one LAN port and some of them that come with two LAN ports and other types of port, XDSL port. Now, these ports are kind of physical interfaces or physical ports. If you're going to configure Patton, you have to configure virtual or logical interfaces, which are then subsequently bound or attached to these physical ports. Now, configuring these logical interfaces, that is done in the context IP router. Okay, so that's how we configure data networking or data traffic. Yeah, data networking in a Patton environment. You have the physical ports. Physical port, just think of them as just for their physical port. But with regards to configuring things like IP address, configuring things like access list, configuring things like network address translation, or configuring things like the routing, how you're going to route traffic from one interface to the other, or even configuring interfaces itself. The interfaces, all these things I just listed, they are defined in the, they are defined in the context IP router. As for interfaces, they subsequently have to be bound to the physical ports, and this we're going to show you later. Okay. Okay, so let's now look at configuring the voice part. Now think of this like you're trying to configure a legacy voice network. What do I mean? You are only configuring things like analog interfaces or ISDN interfaces. So you're only configuring an FXO or an FXS. For now, forget about VoIP. Okay. In this setup, it's almost the same thing as the IP or the Ethernet setup, where you have physical interface, and you're going to have to define logical. Sorry, you have physical ports. Okay, and you're going to have to define logical interfaces in, this kind of came up a little bit earlier. Sorry. Okay. You're going to have to define logical interfaces in the context CS switch. Okay. Now, once you define a logical interface, you then subsequently bind it to the physical port that you want that interface to apply to. And then, if you want, you can then create routing between the interfaces. Okay. So you can get a call coming from one port and then subsequently forward this call to another port. You could instead, rather than forwarding directly from port to port, choose to forward it to a routing table. Okay, you could forward it into a routing table. In that routing table, you could do a manner of interesting things, which we can talk about later, or not, sorry, we can talk about in another session. You could also choose to forward this incoming call to a service. Say you want to do things like play a second dial tone. So you want a call to come in, and the user, rather than having the call forwarded to a destination directly, the user hears a second dial tone, and they can enter a sequence of digits to dial some other number. Okay, that you can do. All right. So this is our context CS switch. Now, in the middle, we have context SIP gateway. Now, the way I like to describe it is you have context SIP gateway is the child of a relationship between context IP router and context CS switch. This is where we bring the two separate worlds of data networking and legacy TDM networking to give you your voice over IP, or in this case, VoIP gateway. Okay. and this is what it looks like. Now, if you look at context IP router or context CS switch, we define interfaces. So if we look at context IP router, we define interfaces. Okay, these are all interfaces that we're defined. These are logical interfaces that can be bound to any port. Okay, on the IP side. Likewise, also on the context CS switch side, we define interfaces, logical interfaces that are going to be bound to their port type. Now, with context CS switch, it's a little bit specific here. So, for example, if you define a logical interface for, let's say, ISDN PRI, you cannot apply that interface to an analog port. Okay, and vice versa. If you define an interface for an FXS, and you define a logical interface that you happen to identify as FXS, you cannot apply that to an FXO port, and that just, it's common sense. Okay. Now, in the context IP router, for example, there are a couple of things we can do, and this all relates to how we are going to treat IP traffic in on our gateway. Now, we keep on using the word gateway with the smart node, but bear in mind that technically smart node can function effectively as a router, meaning it can do a lot of things that you would expect in a traditional router. What do you expect in a traditional router? You expect you should be able to apply some kind of access control list rules to say who can do what for your security, who can access what segments of your network. You should be able to apply some level of quality of service. The idea being you want to give preferential treatment to certain types of traffic. Of course, in most cases, this will be your voice traffic, but you could choose to say, for example, you don't care about voice, maybe your SQL traffic is much more important because you have an SQL server and you have to post transactions in microseconds. Of course, we could also do things like network address translation, or sometimes called port address translation, meaning we want to mask the one side of the network from the other side of the network, and primarily use one or more IP addresses. And primarily have the inside side of all devices inside of the network share one public IP address. You could also, of course, have a DHCP server. Remember, you could have the gateway, the smart node gateway, provide DHCP services to your internal host. And you could also have a VPN. Patton has excellent support for the IPsec VPN protocol. So you could also have a Patton acts as your VPN gateway as well. Okay. Now on the context CS switch side, some of the things we could do is we could adjust the tone set. We could also adjust the VoIP profile, the PSTN profile. Now, just to talk about PSTN profile and tone set, this becomes very important when you are dealing with things like busy tone or dial tone. You might be in certain environments whereby, how I explain it? Okay, the idea being you want, now, let's step back a bit. Normally, when you're in the legacy environment with your rotary phone, when you get a call or when you make a call, and you have a conversation with someone, you have a conversation with the remote party, and they hang up, you hear a busy tone, and that signals to your brain that the conversation has ended, and you should put the handset down. Okay, that's you, the human being, making this decision. Now, when you have a gateway connecting to the telco, the gateway has to have some intelligence to listen to some type of busy tone, to a type of tone or a tone pattern, okay, to make this decision and say, okay, this conversation has ended. By giving this tone, I can for sure say the conversation has ended, and I should close the line and release the circuit. Okay, this becomes important when you might hear cases of clients complaining that at the beginning all my lines are fine, but after people make like 3, 4, 5 calls, I begin to get busy tone, and nobody's using the phone. Nobody can call into the office, nobody can call out, and nobody's using the phone. Usually that has to do something with the tone, and you want to keep that in mind. Okay, so these are the profiles we just talked about. Now, okay, brilliant. So what we're showing here is how we connected, how we bind, and in Patton, when I show you the Patton configuration, we actually define this term as binding. When you bind a physical, sorry, just get that done. Just give me a minute. Okay, I think we have that here. Okay, so when we bind a logical interface to a physical port, this is called binding in Patton terms. Excuse my writing. And the same thing also applies with data or IP connectivity when we bind a logical interface to a physical port. Okay, as you can see, we can bind multiple logical interfaces to one physical port. That's allowed. So the next question that comes to mind is, okay, so we have these two things. We have context IP router and we have context CS switch. One handling data or IP connectivity and the other one handling circuit switching or traditional legacy voice switching. So how do we handle the context SIP gateway? Now with context SIP gateway, you will see when we get into that part that we have two types of two types of what we call SIP interfaces. And one of them is already mentioned here, which is the SIP interface, defined in context CS router, okay, which acts as a bridge between context CS router to context SIP gateway. And we are then going to bind, we're then going to create an interface in context SIP gateway, which will act as a bridge between context SIP gateway and context IP router rather, okay. All right, so let's take a deeper look at context IP router, and I'll just go through this one briefly because we've already spent quite some time talking about all this thing. And this it's kind of it reemphasizes what I just talked about with regards to the context IP router. Primarily handles everything with regards to do with data traffic, moving from one interface to another interface. Now, sorry, let me rephrase, from one port to another port. Now, the ports could have different types of interfaces bound to it, okay? And you could define in the port, you could choose to say you want to have PPPoE, like what I have in my home. My provider gives me PPPoE for my internet service. Or if you are doing, you have multiple VLANs, say for security reasons, you have your, I don't know, you have the device functioning as your main router, and you have let's say the management VLAN, you have the sales VLAN, and you have what else again, the server VLAN and things like that, and you want to have the device act as a, what we call it, router on a stick. You want to do router on a stick. For those of us who come from the Cisco environment, the technical term is called, sorry, the Cisco term is called router on a stick. Of course, you could have Patton provide VLAN services to the rest of your network, and you could bind interfaces to different VLANs. So in this case, for example, this interface is bound with VLAN is bound to VLAN 1. And this interface is bound to VLAN 2. So you can have them sit on two different subnets logically. All right. So what are some of the things we can do in the context IP router? And let me just quickly show you what, for those of us who haven't configured, this is what we're going to be looking at in Patton when we're configuring a Patton device. And I'm just going to quickly show you what we're saying here. Configure. When we're saying context IP router, this is what we're talking about basically. Just going to stretch it up a little bit. Context IP router. So at this point, I'm in this circle. All right. And what are some of the things I could do in this circle? I could choose to create an interface. So I could say an interface, for example, interface LAN, and this is a logical interface. Now, in this interface, I could then subsequently assign an IP address to this interface, say address 1.1.1.1, so that mask 255.255.255.0. I'm fine, okay? All right, so at this point, what I've done now is created one of these circles, or let's focus on this, let's use this one. I've created one of these green dots you have here. That's what I've done. I've created a logical interface, assigned an IP address to this interface. The next thing I do is I'm going to go out for now, and then I'm going to go directly to the physical ports. So in this case, we have port Ethernet. Let's say, for example, port Ethernet 0, 0. That's my first my first LAN port, okay, and then I'm going to bind this interface I just created, and you see these are the various logical interfaces available, LAN 1 to this particular port. Okay. All right. So at this point, I have this black line you have here. This is what I've just done. When I bind it, I've tied or linked this logical interface to this physical port. Okay. All right. Just going to take that out. So, a couple of other things we can do in our context while we're in the context IP router. We can do things like IP routing. So, of course, you're going to have to define routes. At least minimum, you're going to have to define a default route if it's functioning as your router. So you can do things like, say, for example, route. Let's say route 0. Sorry, I think that's wrong. Route. Yeah, route. So route 0.0.0, 0.0.0, and then we specify the next hop. You can do that. All that we can do from here. So now we've just seen in the example we have here that what we can do with what we do when we say context IP router, what we mean rather when we say context IP router, and we define a logical interface which is then subsequently bound to a physical port. Okay? All right. Yes, there are a couple of course, we can do a lot. We can do much more on our router, on the smart node device. But for all intents and purposes, this particular webinar, we're just going to limit it to basic stuff. All right. So now coming to the voice side, coming to the voice side. On the voice side, we can the smart node allows you to do almost similar behavior to what we had on the data side, meaning you have the context CS switch. I always like to say CS switch stands for circuit switching, whereby in that context you define logical interfaces, and these interfaces could be analog interfaces like you have here, or it could be an FXS. Sorry, for analog it could be FXS or FXO, or it could be an ISDN interface. I think it could be an ISDN interface where you have the ISDN PRI or the ISDN BRI. Okay. Now this interface is subsequently bound to a physical port. Okay, and talking about that, you have the context CS switch. Okay, let's come back to our example. So context CS switch. Okay, that's this context CS switch. Okay, so now at this point, let me place it here. Okay, excellent. I hope we can see all this. I don't want to make it too complicated. Okay, so at this point, I am now in this ball. This blue ball you have here, context CS switch. I'm now in this ball. Now what I'm going to do is I'm going to define an interface. Okay, I'm going to define, let's say, an FXO interface. Okay, I'm going to define one of these blue, darker blue balls. Okay, so I'm going to create a logical interface. So interface, the type of the interface. I'm just going to use comma to show you certain things. So you can define the type of the interface. In this case, we have the option to specify whether it's going to be, excuse me. Okay, just get this properly. Okay, brilliant. So we can define the interface and see whether it's going to be an FXO interface type or an FXS or a SIP interface type. Guys, for those of us who are not really too familiar with the concept of FXO, FXS, it's just meant to define what you are going to connect to. So an FXO interface or an FXO interface will be bound to an FXO port, which will always connect to the telco. Never would you have to connect an FXO interface to an end device like a analog phone or a fax machine. An FXS interface is an interface which will be bound to an FXS port, and an FXS port will always connect to an endpoint. Endpoint meaning it terminates at that point. So you could have it be an analog phone or a fax machine, or in some weird cases even a modem. Okay, all right. But never are you going to have an FXS, or never rather should you take an FXS interface and connect it to the line coming from the telco. You could potentially damage your unit because both interfaces actually have some level of voltage. Okay, so FXO, let's say interface FXO here. All right, and I'm going to call this I don't know, let's call this call it my PSTN. My PSTN, okay? All right. So now, at this point, I have defined one of these darker blue balls here you have here. Now, some of the things that are important in this port, let me rephrase. Some of the things that are important which you have to do for your FXO port are things like you have to define routes. Saying, for example, when a call comes in, how is that call treated? Is that call forwarded directly to another port? Or is that call forwarded to a routing table? Okay, and this we'll look at when we're looking at the configuration when we're looking at configuring Patton for 3CX. Okay, but this is what I mean here. So let me just show you that routes. Okay, and there you have routes here. Route call. Excuse me. Route call. Okay. So here what we're saying is basically this. What this means is, when we receive a call, where are we going to send this call to? Are we going to send it directly to another interface, which is possible, or are we going to send it to a service? A service are things that you want. A service could be thought of as things that the smart node can provide for the caller. So the service could be things like second dial tone. Okay. So a call comes in, you want the caller to hear a second dial tone, and they can then choose to enter a sequence of digits, and then the call is subsequently forwarded to another user. This is cool. This is quite important to some clients that have what we call the toll bypass solution, where they have an office in one branch and they have another office in another branch, and they want users in one branch to be able to make calls to the public users on another branch. I've dealt with some clients whereby they want the callers to hear a second dial tone so that it's clear to them that they are making a call on the other side, maybe for billing reasons or for whatever. Okay. And finally, we could forward the incoming call to a destination routing table. Okay. All right. So in this case, I'm not going to do any of such because I haven't created any interface. I'm just going to leave it blank. Okay. All right. But now we've created our interface. Now, after creating our interface, the next thing we do is the final part of the equation is we bind the interface to a physical port. Okay. So I'm going to go to my FXO ports FXO. Let's say 0, the first FXO port. Okay, and I'm going to bind interface, and you have, bind my interface to this port. Okay, something else we need to do. We need to set the encapsulation. Encapsulation CCFXO. Done. So at this point, we have completed the chain. Okay, basically what we did, we started with how did we start? We came into context here switch. Okay, and then we defined an interface in context here switch. Okay, and then we talked about routing incoming calls. Okay, and finally we attached that interface to a physical port. Okay, so this is 1, this is 2, and this is 3. Very simple. All right. Excellent. Okay. Now, in context here switch, there are a couple of things we can do. Of course, we can create a call routing table. We can create a call routing service, as well as we can also manipulate our call. Meaning, we could do things like, for example, change the caller ID or reformat it. I've been involved in some projects whereby, especially with ISDN PRI, where the provider expects your outgoing caller ID. For outgoing calls, the provider expects the call ID to be set to a particular digit. Okay, if they don't have any DID, and anytime a call comes in and the call ID is not set to this digit, the call is rejected. And in most cases, the provider does not give you a reason why the call is rejected. It just says normal clearing. And we've had cases like that where we then realize that actually we have to reformat or reset or change the outgoing call, the call ID for the outgoing call. Okay. All right. All right. So just an overview of some of the things we just talked about. Context CS switch. What we do in context CS switch. This is our smart node call router. You have calls coming. VoIP interface. We haven't talked about the VoIP interface yet, and I'm going to talk about that in depth very soon. And then we can connect to we can define different types of logical interfaces, and subsequently we can then choose to define a routing table, okay, or mapping table, and we can also define services. Now these things we didn't talk about, mapping tables and services. This will be talked about in future webinars. All right, so this is an example of an FXS or both FXS, the configuration requirement for FXS or an FXO port. This is kind of like an illustration of what we just talked about. Here we define, we go into context CS switch, we define a logical interface, which is then subsequently bound to the analog port. Okay. Now you could see, if you see this part, CCX, the encapsulation, CCS FXS for an FXS port, and CCS FXO for an FXO port. You saw with the error we got earlier. Okay, that's the encapsulation that is defined here. Okay. All right. Now, talking about context SIP gateway. Context SIP gateway is where we bridge these two networks. Okay, so you have the legacy voice network services or network environment, and you have the IP network environment, and we have a VoIP gateway. This is how the VoIP gateway part comes into play. So what we said VoIP gateway is what? You take voice and make it another application on an IP network. Okay, so context SIP gateway sits in between, or will sit when configured in between the context CS context CS switch and the context IP router. Okay. For now, let's just overlook. Just for now, just bear with me. Overlook everything above this red line, and let's just focus on what we have here. Okay. So notice that on the context CS switch, we have an interface. We have an interface which we define. Now this interface is interface type SIP, which is defined in the context CS switch. This interface is where we bind the SIP gateway that we define. Okay? All right. Now in the SIP gateway, we'll also define an interface, and on that interface, we're going to bind that interface to our IP our IP interface. Okay. All right. What am I saying here? So let's look at what we're talking about. So I'm going to scrap all this. Let's go back here. Okay. All right. So context SIP gateway. I'm just going to call it gateway. Let's call it gateway demo. All right. All right. So now at this point, I'm in the trapezium or the inverted trapezium we have here. Okay. Context SIP gateway, and we name it gateway demo. Okay. Now, if you look, let's just okay. So what are some of the, and by the way, what this means is in the current mode we are in, these are the commands that you can apply. Every other thing above are legitimate Patton smart node commands, but they cannot be applied in this configuration mode. Okay. All right. So what are the kind of commands we can apply? We can apply the bind command. Okay. Bind is for location services, which we will look into. That's what we have above the red line. Okay. And we can also define an interface, okay, SIP configuration interface, okay, and we can shut down or bring up or disable or we enable an interface. Quality of protection, we will not talk about that. So let's look at interface. I'm going to call this interface gateway SIP. That's a SIP gateway interface. Let's call it interface 1. Okay. All right, and let's see what we can do. What can we do on this interface? We can bind again. All right, see, that's what I want to emphasize. We can again bind. Now, what I did is I'm now going to provide the link or the connection between this and this. That's what I'm about to do now. Excuse me. Sorry about that. Yeah, sorry about that. Okay. All right, so back to this. So here I'm gonna bind. Okay, bind interface. I can specify which of the interface I want. So in this case, let's say the LAN interface. I want to bind to the LAN interface. Context is always IP, and I can then specify the port. Now, if I say, for example, 5060, what this OP does basically is this. At this point, Smart Node will begin to listen on TCP or UDP, okay, and that can be configured as well. TCP or UDP port 5060 for incoming services, okay? And for those of us that are coming from the link environment, you can also change it to whatever you have on your link environment. I think by default, link use 5066 or in some cases 5068. That's what it means, okay? At this point, you literally open a socket on Smart Node and you're saying, okay, now I want you to start listening to incoming requests on these ports, incoming, okay? All right, that's what we've done now, okay? So now what we've done is we've literally kind of said, okay, yes, we want this. Let's go back here. We are now binding our context SIP gateway. We're binding it directly to, an interface on the context IP router side, okay? All right. The next part of the equation is to bind the SIP gateway, or the context SIP gateway, is to bind it to an interface on the context CS router side. So let's do we have context CX switch, excuse me. All right, context CS switch. I'm going to go into the interface I created. I created an interface earlier on. Interface was a SIP interface. Oh, I didn't save that. Oh, no, I did not create an SIP interface. So I'm going to create a SIP interface. So let's call this a circuit switch SIP. This is a circuit switch SIP interface. This is my own type of nomenclature. So I know, okay, this is circuit switch SIP interface. And the other one is context SIP gateway interface. Okay, that's why I start that with the GW. Okay, so now here, one of the things I can do here is bind, okay? Context SIP gateway. I think it's, what was it called? Gateway demo, GW demo. Okay, at this point, I have completed this part. That's what I've done. So now I have the link, okay, between legacy voice services and modern VoIP services. So on one side you have legacy voice, and the other side you have modern VoIP, in this case services. Okay, so now this is just basic stuff. This is just part of the things we have to do. Of course, we will have to define how to handle incoming calls, how we're going to route incoming calls. Okay, so we're going to say, for example, route incoming calls to, let's say, in this case, we're going to route it directly to a destination interface. We're going to route it directly to an interface. Let's call this interface my PSTN. Okay, so when we get an incoming call, let's look at what we've done now in this by doing this configuration. When we get an incoming call on the port we defined in our context SIP gateway, we defined, I think we use 5060. When we get an incoming call on UDP or TCP port 5060, the call is going to be forwarded directly to the interface called myPSTN. Okay. Now, myPSTN on its own part is bound to an FXO 0/0. Okay, the FXO port 0/0. Okay. All right. So next, how do we handle outbound calls? Now, outbound call, it's the same thing will have to happen. A call comes into the system, and you're going to route it through maybe directly to a destination interface or to a routing table. But the question is, how does the system know which IP address? Remember, this is a SIP. This is a SIP. This is a SIP interface here, and SIP interface they don't bind to a physical. What's the word? They are not bound to a physical port. Instead, they are bound. They connect using the gateway, SIP gateway, to the IP port, to the IP environment. Okay, so it's not out. Okay, so we do that by using the command remote, and then we specify either the host name, say for example 1.1.1, and the port number. So this is how we handle outgoing calls. Outgoing calls. Okay, we specify the remote ends, either the fully qualified domain name or the IP address, as well as the port number. Okay, so let's say remote 1.1.1 and TCP on port 5060. Okay, all right. There are a bunch of other things we can do on a SIP interface. I wouldn't put too much. Oh, okay. Yes, that's correct. That's correct. Thank you, Yara. With regards to the configuration, yes, yes, I know CLI configuration sometimes can be a little bit difficult to follow, but we encourage you to start working with Patton from the CLI. As Yara explained, it provides a better understanding of how Patton operates, how Patton functions, and then you can move to the GUI environment. Okay, and when you get to look at it, you break it down to simple and smaller bits. You realize that it's relatively it's not as complex as it seems. Okay. All right. Okay. Now, so let's look at let's talk about what we have above this red line that I said please ignore. Okay. Now we have. Let's start with the extreme end. We have something called authentication service. The authentication service is basically a database. Think of it as a database where you enter SIP user credentials. Now, for those of us who are not familiar with SIP, generally SIP, you have the option when a SIP device, a SIP client boots up, it could register, or it could register and be authenticated. It has to. Let me rephrase. It could register and advertise itself to more or less advertising itself to the SIP registrar, be it a gateway or a PBX, basically saying, okay, I am here, for example, extension, let's say extension, I don't know, let me see, let's say extension 401, IP address is now mapped to 2.2.2.2. This is one way for the gateway to know the IP address of the remote end. Another way is if you manually do it. Okay, that's like, for example, what I did. So the authentication service is basically a database which can be used to authenticate incoming requests or call requests to the Patton Smart Node gateway. And likewise, in cases where the Patton Smart Node gateway has to register or has to authenticate outgoing calls or registration requests to an external ISP. Okay, this is where you define your credentials. You put the credentials here, username, password. It's just basically a database. Think of it as a database. Okay. Now, location service is what we use to define characteristics or behavior of our context SIP gateways. So, for example, what are the characteristics we want? For example, let's say we want to enable the SIP registrar service. That means you want the Patton gateway to behave as a, let's say, a scaled down or a dumbed down version, or a dumbed down PBX. Basically, that means it can have your internal IP phones register with it. Okay, that's a characteristics you are adding to this particular SIP gateway context. Okay, so that you define using location service. Okay, and that is subsequently bound to the gateway. Okay, so what do I mean? I'm just going to run a quick example here. We're almost running short of time, so I wouldn't put. What do I mean by that? Let's come out of here. So let's say authentication service, my auth service. Okay, I'm going to say, okay, I'm going to define username. Let's call it username extension 401. So you want to use this as a SIP registrar extension 401, and we're going to say, okay, password is ABC123. Guys, never use this in production, as this can easily be hacked. Okay, this is just a demo. All right, so don't say you saw me do it and hence you're doing it, please. Okay. All right. All right, and we've defined our authentication service. Of course, you can define multiple usernames and password. Okay, and the authentication service is then going to be tied to our location service. So I'm going to call this. I'm defining a location service called LOC. Let's just call this my LOC location. Let's just look at location server. Okay, all right, and what am I going to do here? I'm going to create an identity. Let's just an identity group default. I wouldn't explain what I'm doing here, but just work with me here. Registration inbound. Now here I'm saying I'm going to register inbound calls. I'm going to register incoming registration requests. I'm going to accept incoming registration requests. Okay, and I'm going to authenticate them using the authentication service. No, sorry. Authenticate. I think that's it. Yep. Authenticate inbound. Okay, and then I'm going to use this authentication service. Authenticate. No, I think that's.
I mean, it should be outbound for outbound.
Sorry? I'm sorry?
It should be outbound for outbound authentications. You typed inbound?
For SIP registrar.
Mm-hmm. No.
SIP registrar is inbound authenticated. For SIP registrar inbound, it's inbound or outbound?
No, you're registering to a provider, right?
No, I am acting as the provider. I'm acting as the provider. I'm acting as the provider. So I'm having like you have like a backup phone. You have like backup. What do you call it? Backup. Backup. Come on. The backup. Come on, think. You have the Patton Gateway acting as a backup SIP registrar, backup PBX for remote branches.
Okay.
Okay. All right. All right. So now I've tied the authentication service that I created. Oh, sorry. I've tied that service to my location service. Okay. Now then I'm going to context SIP gateway, and let's just go back to that gateway I created. Gateway. Yep. No gateway. Okay. All right. Now I'm then going to bind the location service I just created to the SIP gateway. Basically, I have changed the characteristics of the SIP gateway here. So it's now going to accept incoming registration. Of course, there are some other things you will have to do, but I'm not going to go into that, okay? But that just gives you an illustration of what we're talking about here with regards to authentication service, location service. Authentication service, think of it simply as a database where you put user credentials, username, password, or in some cases you might just put username, and if password is not required, you don't have to put password. The authentication service is tied to the location service. The location service is where we define characteristics of how we want our SIP gateway context to behave. Do we want outbound authentication for calls? Do we want inbound or outbound authentication for registration requests? Now, registration request inbound is when we want to have the Patton Gateway act as a scale down or DOM PBX. Basically, it's going to allow your internal phones to register with it, and it can route calls between extensions, and it can also, for example, when someone calls from the PSTN, route that call to a particular extension. Nothing fancy, so don't expect things like enhanced IVR and call detail records. No, nothing fancy like that. Just a scale down or dumb down PBX. Okay, that's what you get here. All right. Okay, so questions? Any questions? Yes, that's correct. It did. Yara did answer that question. Rurel, I hope I'm pronouncing your name correctly. Yes, it does, and it can act like a SIP registrar. In fact, by default, when you buy a Patton, the Smart Node, it comes with the SIP registration option to register up to 4 devices simultaneously. If you want to register more devices, then you will have to get a special license from Patton. Okay, and Yara can help you with those details if required. Okay. Okay.
Fahmi, we have had many questions. I've answered them all, I believe, but we had a request for the web GUI interface. So I believe maybe since you're connected to a unit, I don't know if you can show quickly the web interface, how it looks, and
sure. That we can do. That we can do. Let me just excuse me. I'm gonna have to take this off. I think I have it somewhere here. All right, here we go. All right, so this is the same device I was just connected to. Okay, this is the web GUI interface, and you have literally, I think Yara can correct me if you can get 100% functionality on the GUI as you have on the CLI, but in my opinion, you can get almost close to 80 to 90% configuration options from the GUI as well. How do you connect to the remote CLI? Okay, with regards to remote connectivity, there are two options. There are two options to connect from the CLI. When Patton Smart Node devices come with the console ports, so you can, and whenever the Smart Node, for example, I'm using the Smart Node 4524. It comes with the console port. You can connect a console cable to the DB9 interface of your PC or laptop, and console in, okay, COM1. All right. Patton also has support for SSH as well as Telnet access. Okay. All right. So speak back to the GUI. We can make a lot of the configuration changes we just did on the GUI. So let's look at, for example, IP connectivity. Now, IP connectivity here, we can define our interfaces. By default, when you have the smart node, the one I'm working with, it comes with two LAN ports, and these ports are defined as ETH. Sorry, let me rephrase. It comes with two LAN ports. That's correct. But it also comes with two logical interfaces pre-configured. Okay, ETH1 and ETH0, ETH0 and ETH1. Okay, and ETH0 is gets its IP address via DHCP. Okay, so that means you have to, if you have it connected to your network and you have a DHCP server, it's going to get this IP address via DHCP. Some of you might ask, how do I get to, if I have if I have it connected via DHCP, how do I get to know the IP address? Patton have already helped you out here. They have an excellent utility called the Smart Node Discovery tool. You just run it on your laptop, and it automatically goes into your network to find all Smart Node configured devices, and it returns with their IP addresses. So if you have your smart node connected to the network via the ports that supports DHCP, you are also covered as well. Okay, this is what I'm talking about here. Okay, I'm sorry, excuse me, Smart Node Discovery tool. All right, good. Okay, so let's come back to the LAN interface we just created. You can interact with your interfaces by just clicking on it. You can specify the IP address for the interface, and you can do other things as well, okay, which I wouldn't go too much into. Okay, so we have created our IP interface. Okay, so let's, for example, create another IP interface called WAN. So it's already there. And here we go here. Okay, we got WAN, and this is, I'm going to call it, let's see, I'm going to call it, let's call it, put IP address 136.1.102. Let's say 4. Let's give it a subnet mask of 255.255. Brilliant. Okay, we'll have it there. And that's done. Now I'm not going to come here. I'm going to check this out. So, okay, use define IP address. I'm going to apply that. And we can come back here to IP. And we have our interface defined. The interface is defined. This is the IP address. Okay, so we've now defined the logical interface. Back to what we talked about, we're going to bind this logical interface to a physical port. And these are the ports we have here. You have the Ethernet port, you have the FXS port, and you have the FXO port. Now, the ports you have here would vary depending on the type of gateway you have purchased from Patton. Okay. All right. So in our case, I'm concerned with the Ethernet port. I just need to come here, Ethernet port, and I'm going to bind it to one of these interfaces. Okay, let's say for this interface, interface 0, so I'm just going to take it here and boom. So, okay, all right. And then I'm going to apply it. I'm not going to apply it now because I don't want to lose my connection, but I just apply it and we're good. Okay, so we've done the same thing, similar to what we did on the CLI configuration. Now for the call routing services, that's what you have here. On that occurs under telephony. Okay, you have the call router. All right, you can define interfaces. Now the interfaces you can define will depend again on the type of gateway you have, whether it's FXS, FXO, SIP. Of course, in most cases you always be able to define SIP interfaces, but there's also the option to define, I think, ISDN, PRI or BRI interfaces. So in our case, let's say we want to define an FXS interface. Okay, so maybe we have a fax machine, for example, we want to connect it to. So I'm just going to say CS circuit switch FXS, CS circuit switch FXS underscore interface, and just call it fax. All right, and we got that done. Okay, so now we've defined our interface. The next thing we do is to say configure some characteristics of this logical interface we just defined. So for example, incoming calls. How are we going to treat incoming calls? I want, in this case, let's say I want incoming calls to go directly to an interface. Okay, I don't think I've created a routing table. Okay, so I want to go directly to an interface. Let's say I want to go to this, directly to the PSTN interface, my PSTN interface. All right. So incoming calls, we go to that interface. Some other things you might have to do, just since we're already here, you might have to play around with the call ID settings or call ID formats. You can do this from the CLI, but from the GUI is of course much easier. Different countries or different telcos have different options for call ID. Some of them DTMF. I think that's predominantly used in Saudi Arabia, but most countries use Bell and ETSI. Okay, all right. Okay, so we've handled incoming calls, and we applied that. All right, brilliant. So then, as we did with the data interface, we subsequently bind this logical interface to a physical port. Okay. Now the interface we created was an FXS interface, which is what you see here. It's an FXS interface. So of course we're going to bind it to an FXS port. All right. So let's bind it to the first FXS port we see here. I'm just going to take this port state. First of all, you have to of course enable your ports. The encapsulation CCS FXS. All right. And I'm going to bind it to this interface. All right. Voila, we're done. Okay, so this is just a quick rundown on how we can do the same things we did on the CLI on the GUI as well. Okay, now with regards to integrating with 3CX, which is part of a very important part of this discussion, we've already exceeded our time, so I wouldn't go into showing you the exact configuration on how to integrate it with the 3CX environment, because to be honest, we've already discussed this. But I'm just going to mention some key points you have to keep in mind when integrating with 3CX. Okay, now with 3CX, yeah, here we go. This is a 3CX environment I have that I've set up for this place. With 3CX, the first thing, 3CX has primarily, there are two ways in which you could, or I wouldn't say there are two ways, but there are a couple of options, two options, let's just put it like that you can integrate 3CX with Patton. For one, 3CX has the option whereby it automatically generates configuration file based on the Patton configuration file based on your 3CX settings. So for example, let's say I want to integrate, I'm going to say add a gateway. I'm going to I'm going to name the gateway. Okay, let's call this my Patton box. My Patton box. That's the name of the gateway. Select the brand. Scroll down here, and 3CX just to sidestep for a minute. 3CX has the option to support gateways for multiple vendors, okay, as well, not just Patton. Okay, so keep that in mind when you're making your decisions. Okay, so Patton. Okay, I select the model that I want to support. Let's say 4-port FXO. That's 2FXO, 2FXS. I need 2FXO, 2-port LAN, and 2FXO, 2FXS. Let's see what we got here. I'm just going to go with this one for now. Let's just use this. Okay. This is actually not my model, but I'm going to use this for now. Okay, to speed things up. Okay, so this gives me configuration for 2FXO ports. Okay. All right. So what tones do I want? Okay, I'm going to keep it local to my environment. Okay, they don't have anything for UAE, but I could use United Kingdom, which is almost the same. Define my caller ID setting. All this you could choose to leave at the default. Next, and then specify the IP address. Now, coming here, the IP address of this device is 192.168.102.156. So I'm just going to copy that and paste it here. Brilliant. I'm listening on port 5060. Okay. Then the number of ports I have on this gateway. Okay. This is quite important. So, for example, even though let's say you have a 2-port gateway, but you only have one line connected, you might want to change this to 1. Okay. Just keep that in mind. Okay. So let's leave this at 2. Okay. And okay. Now these are 3CX related extension. What 3CX does basically when it's automatically creating the configuration file for Patton is, depending on the number of ports, is going to create an equivalent number of SIP trunks, okay, between 3CX and the Patton device. So in this example, we chose a 2-port FXO gateway. So 3CX will create 2 SIP trunks between itself, 3CX, and the Patton gateway, okay? And in this case, it's saying, okay, it's authenticating using an authentication username of 9005 and 9006, and this is the password. Now, what does that tell you? If you were configuring this, what that tells you is this: that at this point, when you are defining your configuration on Patton, 3CX will generate the configuration. But what that tells you is you're going to have an authentication service created with a user with two, at least minimum 2 user accounts, okay, 9005 and 9006 with those passwords, okay, for the authentication service. Remember, we said the authentication service is basically a database, okay. All right, that's what was going on here. All right, and then we specify how we're going to handle outbound calls from 3CX. So, for example, do I want to limit this to? Do I want to say that this particular connection is only to handle mobile numbers within the UAE? So calls to numbers starting with 050, and maybe it's only specific users. Let's say only the manager can dial mobile numbers. So let's say the manager's extension is 8401. Okay, and the call to the number of that we can skip all that. Okay, and the call should be routed so the call to this gateway. So basically, what we're saying is anytime this user and only this user extension 8401 dials any number starting with 050, or in this case, let's just make it 05 because we have 055 and 056 in the UAE as well. So any number that starts with 05 is going to go outbound using this particular gateway. Okay, we're not going to strip any digits, and neither are we going to prepend. Okay, all right. So once I finish this, now when I finish this and I say generate config, what 3CX automatically does is yes, okay, fine, that's fine. It downloads, it generates a config, okay, and it pushes that config to me to download. Okay, this is the configuration here. I'm just going to open it. Let's open it with Notepad or WordPad. Open. Let's use select program from. Yeah, let's use WordPad. Okay, there you go. So at this point, what happens here is 3CX automatically generated the configuration file, okay? Entered all the necessary information, okay, for the Patton smart node that was selected, okay? Including the IP address, including things like, if you look at, for example, here you go, this is the authentication service I talked about. You have authentication service and you have the username, forget about the RAM. Let's look at the username. Username 9005, 9006. Okay, and this is the password. Okay, this authentication service is subsequently bound to a location service. Okay, and the location service is subsequently bound. I don't want to focus too much. It's subsequently bound to a gateway. Okay, here we have the interface line and context gateway this, and we're binding this location service to the gateway. Okay, all right, okay. So, and this is that is how 3CX does it. The next thing you have to do is you subsequently have to import this file, and you can do this from the GUI. Import the configuration file you just got, import it into your Patton device, and reload. Do not save, okay? Because what it does is it imports it to the startup config, and you can reload, okay? And you're good to go, all right? So that's about it. That's how we can get 3CX to easily integrate with. That's how we can get 3CX to easily integrate with Patton environment. It's relatively easy, not complex, in my opinion. And you can choose to go for configuring Patton. You could choose to go from configuration from the CLI or from the GUI. Okay. Thank you very much, and I think Yara can take over from here. On the ports.
Okay, thank you very much, Femi. We have one question related to 3CX. Maybe you can answer it. The question says, when you're configuring 3CX with gateway as a SIP trunk, how would you register the gateway on the 3CX? How do you configure it as a VoIP provider or as a trunk?
Well, technically, you can have it. You can configure it either way. But if you want 3CX to generate the configuration files for Patton, the Patton gateway, okay, you have to configure it as a VoIP gateway. Okay, if you want 3CX to automatically generate the configuration files for the Patton gateway, okay, then you have to configure it as a VoIP gateway. But if you are, you want to be your own man or woman, by the way, and you want to configure it yourself, configure Patton yourself, and configure 3CX yourself, technically you can configure it as a VoIP provider or as a VoIP gateway. Okay, because in both cases it's still SIP.
Okay, thank you, Femi. Anybody has any further question? I guess all questions have been answered.
I see one here. Hi, using Patton as a SIP trunk gateway for 3CX. How would you register the Patton gateway on the PBX? Registering as a VoIP provider? Oh, okay, I think it's the same question we just answered.
Yes.
Okay. All right. Okay, good. So it doesn't matter if it's PRI or SIP trunk. Could you repeat that question again? Of Ahmad, please, if you don't mind, could you clarify what you mean by so it doesn't matter if it's PRI or SIP trunk? Could you please clarify what you're trying to ask about?
Ahmed, maybe if you could repeat your question. It's not clear. I guess PRI trunk would be a PSTN gateway if you're connecting to anyone from Etisalat, let's say. But maybe if you can repeat the question.
Gateway VPN. Okay. I have 3CX connected to Google from the SIP trunk. Okay. Oh, okay, okay, all right. So if I understand you correctly, you have 3CX in your internal network, and you have a connection via SIP trunk to Vodafone. It's up to you. You could, of course, have 3CX like you've already done, directly connected via SIP to the telco. But from a security and from a masking, or you want to draw a demarcation line between your network and the provider's network, you might want to put some device in. Now, technically, this it's almost the same thing like a VoIP gateway, but in terms of behavior, the actual technical name in most cases is called the session border controller. Basically, a session border controller is, in terms of behavior, is quite similar to your VoIP gateway, but it's sitting at the boundary of two VoIP network types. Okay, so you have your internal VoIP and you have the external VoIP, or your provider VoIP. And can Patton do that? That's correct. Yes, Patton can do that. You can have Patton provide VoIP, act as a session border controller to sit between the boundary of your internal network and the provider network. Okay, let me see the level. Let me see. Okay, I have 3CX. Okay, that's, I think so. Ahmed, let me know if that answers your question. I have another question from Gayat. I hope I pronounced your name correctly, and forgive me if I don't, if I'm not pronouncing it correctly. Okay, if you have a server installed in a remote location and you want to use the gateway here, unfortunately, with regards to UA, and this is as a result of their laws, SIP is blocked, and the only way you can get it to work technically, and I'm speaking technically, legally, and what the legal implications are, you will want to check with TRA before you implement with regards to what is legal with regards to toll bypass. The only way you can get this to work is to have a VPN between your UAE office and the office where the 3CX device is located. Okay, and this is strictly technical speaking, because I know they do have some legal restrictions on what you can do with voice over IP in the UAE. Okay, or you would have to need you definitely need some kind of VPN service to get it running. Now, does Patton Smart Node come with VPN option? Yes, it does. I think, however, that will require an additional license if you want the IPsec VPN functionality to be enabled on your Smart Node gateway or Smart Node router. Okay. 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 Can you advise? Sorry for that question. Mamon, I'm not really familiar. I can't really get that question. Can you advise us on how to generate gateway for different kind of ports by 3CX? Could you please clarify? If you are saying how to generate a Patton configuration file from 3CX, it's quite simple. All you need to do, and are you guys still seeing my screen? I hope you're still seeing my screen. Let me just check if I'm still sharing it. Share my screen. Yep, it's still shared. Okay, brilliant. So you can still see the screen. All right, so it's quite simple. All you need to do is just select Add the gateway, name of the gateway, select the vendor, and 3CX, they have a list of vendors that they support. Gateways from different vendors that they support, and this is the list here. Okay, and select, in this case, Patton, and you select the device that you're interested in, okay, that you want to generate the configuration. Once you do that, just follow the easy next step. 3CX is what I call a very user-friendly PBX. So you just need to follow the easily described next options, and automatically it generates the configuration file for you. Okay. All right. So I hope that answers your question. And which model can you advise which model will support that? And that's from Ahmed. Yeah, could you take that answer that question as well? Which model you recommend for session border controller for Ahmed Yusuf?
Yeah, I will be answering him.
Okay, brilliant.
There are different models. It depends on how many codes he wants to support, if transcoding is required or not.
Okay. How would you define a route table in order to bridge a call from and to specific ports in to 3CX and vice versa? Oh, okay. So if I get you right, well, you're saying, for example, let's say you have, I don't know, let's say you have two companies or two departments that have that same company, but they want to, for billing reasons or for whatever reasons, they want to use different ports when communicating with with public users. So you want, for example, incoming calls to go to sales from port 1 to go to the sales department, and incoming calls for port 2 to go to the support department. Okay, I hope that's correct. And also the same thing applies for outgoing calls. Now, if you remember, when we created this the configuration file, when we created this gateway, the one we defined here, I mentioned something. I think it's better if I just generate a new gateway. Okay, so I'm going to create a new gateway, and we're going to say, okay, this gateway, this is a pattern box. Let's say, for example, we have a 4-port FXO. Okay, and I'm going to call this my cup. Oh, I'm sorry, excuse me. My comp pattern. All right, good, excellent. So here we go. This I'm just going to stick with the UK, and this is just my preference. Next, and the IP address. In this case, I'm just going to use a bogus IP address since the device I'm working with doesn't actually have 4-port FXO. But let's say 192.168.102. Let's say 10. Oh no, you know what? I'll keep it the same device. I'll keep it at the same IP address. Okay. Number of ports 4. Now, when we say number of ports equals 4, what we are doing is we are creating, if I were to, let me just look for Paint, MS Paint. Okay, so what we are doing is we are creating, excuse me, yeah, we are creating, yeah, this is, let's say this is your 3CX, this is 3CX, and excuse my drawing, and this is pattern, okay? So what we are doing is we are creating, when we say number of ports equals 4, is we are creating 4 SIP trunks between 3CX and pattern. Okay? Now the configuration file that it generates is going to map each SIP trunk to one physical port. Remember, this is a 4-port pattern gateway. Okay? So each SIP trunk will be mapped to one physical port. Okay? All right. Excuse my drawing, but I think we'll get the picture. Okay, these are the physical ports that I have in, I think, purple here. All right, it's mapped to a SIP trunk. Okay. So you can then decide in your routing table when you're defining your outbound routes which trunks you want to use. So, for example, if I want the first 2 trunks to be used by, let's say, let's complete this and next. And okay, let's go finish. Okay, generate config, and that's this done. All right, excellent. So at this point, what we've done, going by the diagram I gave you here, is we have 3CX on one side, and we've created 3 SIP trunks, which have subsequently been mapped to, 4 SIP trunks, which have subsequently mapped. Each SIP trunk has been mapped to each of the physical ports you have on the device. So you can then come to pattern, to 3CX, and say I want to create an outbound route. Let's see, for example, outbound routes, and I call this, let's say this is sales. This is sales, okay? And I can say the only guys who can use this route, now this calls to numbers on this prefix. So this could say, for example, any number that starts with 9. So if you're in an environment, let's say the sales guys, to get an external line, they have to press 9. They have to dial 9, okay? And the sales department, their extension numbers are, let's say, extension 101, extension 102, and extension 103. So only these 3 users will be able to use this route for outgoing calls, okay? And then the next thing we do is we're going to strip out the first digit. This is very important. And we select which route they can use. Now, this was the one we created, which gateway they can use. It was my com pattern box. So now when any of these 3 users, extension 101, 102, as well as 103, dials any number starting with 9, the system is going to forward the call to this gateway, and it's going to strip the first digit, in this case 9, before it forwards the call. Okay, so this is how you get to achieve that. Okay, how would you define routing table? So this is how you get to do that. Now, for the technical department, it's quite simply the same thing. So let's call this tech. Same thing. Let's say so tech. You call this excuse me. Okay, so this is an outbound route for the technical department, and I'm going to do the same thing 9, but now the extensions will change. So I'm going to use the example extension 211, extension 212, and extension 213. So only these users can use, when these users dial, 3CX is going to look, and this is okay. There's something else we need to check out here. This is outgoing call. Excuse me, something wasn't defined here that we overlooked. I'm sorry, something wasn't defined here that was overlooked. Okay. But the general idea is we want to have different trunks, okay, for each of our users, okay? So you can basically bundle the trunks and say, okay, outgoing calls for specific users, use this trunk. Outgoing calls for these specific users, use this trunk, okay? The same also apply for incoming calls. Now, there are some things that we didn't talk about with regards to 3CX. Sorry, how 3CX expects, what 3CX expects for incoming calls, how to handle with regards to inbound routes, okay, and IDs. We didn't talk about this because we're already we've crossed our time limits. So this we can talk about in another seminar, webinar. Yara, I think Yara can, as well as the rest of the team, can look at what we can do with regards to details on what else is, what was left, what was not discussed.
Yeah, you're right, Femi. Actually, the purpose of this webinar was just to give you an overview of the different applications with 3CX and what can be done, like the very basic things, configuration things between 3CX and Patton. As Antoine mentioned at the start of the webinar, we do have a Smart Node certification training. This is an in-depth technical training covering the installation, the configuration, and troubleshooting of the gateways. So if you're interested in attending such a training, we can definitely schedule a session in collaboration with Sitec, a Smart Node certification training. Besides that, Femi, I think we have covered and answered all of the questions. If you have or think of any other question later on, you can definitely contact Sitec team or ourselves on MENA, MENA at patton.com, and we'll be glad to answer your questions. So we're 30 minutes past time, so I think now since we have no further questions, we can end this webinar. Thank you all for attending. We have a question from me. We will appreciate if you can send feedbacks, things you would like us to discuss maybe in future webinars. We will really appreciate all that information and what you think we should cover in terms of your environment, irrespective of wherever you are. We'll gladly appreciate that. Okay. Okay, thank you all for attending, for joining this webinar. We will keep you informed of any new webinar to be organized soon. Thank you all. Thank you, Femi.
Yeah, thank you, Yara, and thank you, Antoine.
Have a nice afternoon, everybody.